So that's right here. So that looks pretty good. Now the other thing I was looking at was checking the voltages down here on some of these guys down here. Now one of the things I noticed is that this thing really had super high, it was reading high in terms of its resistance, this 1 watt, which is this guy right here. I want to check to see what its voltage is. Let me check the B+. So the B+ comes off of where those two capacitors are tied in their positive sides, so that'll be like right here, I believe. So the B+ is 225. Okay, let's check on the other side of that capacitor, that resistor. That'd be right here. I don't know. 5 volts. That seems a little low, huh? So that would be coming into the let's see, that goes to both pin 3 of the converter and pin 3 of the IF, because they both come off the same tag. Let me put in a different, let me read that resistance again, and then I want to see about putting another resistor in here and see what we get difference on that output, because that seems a little low, huh? Check again. 5 volts positive DC. Yeah, okay, so that's supposed to be a 33K resistor, that big 1 watt one, and I'm measuring 100% more than that. So I'll change this out. While I'm at it, I'll change the cap that's connected to it as well. This one right here, 24, which is 0.1 microfarad, 400 volt. I'll change both of those out. And I was just looking at the specs on the on 6A7. I don't know if you can see this. I think it's where I can see if you can see this. You see that? Okay. So here's a spec on the 6A7. And what we're looking at is we're looking at pin 3 on this. Let me see if I can zoom into this. Focus. Okay, so pin 3 is the screen grid. Up here for the, I guess you'd say the mixer section. So let's go down and check what kind of operating voltages you should expect at 3. And while we're at it, the plate is 2. So let's just check. So go to the next page. Here's typical operating conditions. So the plate should be between 100 and 250. I think I had 2 1/4, so we're okay there. But the screen is GS, screen grid that we looked at, and it should be between 50, am I doing this right? Yeah, between 50 and 100 volts. See that? I got 5. So we may have found some reason why that one doesn't want to run, huh? So let's see if replacing that resistor would help some, because we're not getting enough voltage. Sorry. Let me see if we can do this right. Okay, so we got decent voltage here on the B+. On the other side of that resistor, we're only at 5 volts here, and we should be 50 to 100. So we're going to look at that. We'll look at that. Yep. Let's look at those two and see if we can't get a difference in that voltage there, and see if that would help get these two to work better. At least that one, huh? Okay. Okay, let's get these two replaced. So this is a yep, confirming it's a 0.1 microfarad cap. So I've got an orange drop here that's a 1 0 with 4 zeros after that would be a, let's see, 1 0 with 4 after it, so it'd be 4, it's 0.1 microfarad, and it's 600 volts, so that'll work good for that. What you're doing is you're adding, in these capacitors, what you're doing is you're adding up picofarads, and it gives you microfarads. You go through picos, and you go through nanos, and you're into micros. And then this is to be a 33K, and so we've got 330. Oh, it's a 5-band. So you got 330 and 5. Sorry. So yeah. So that's 330 and 2. So 33000 is 33K. You can double check it. See how close it is. I didn't grade it yet. See if it's... So we're getting voltage measurements. Be nice to see what the differences are. 33.2K. That's not bad. I think it's a 1%. Not that it's necessary. I think it calls out a 10%, but maybe even a 20%. All right, that'll work. All right, so let's get these guys in here. Like I say, since I'm not doing a big restoration here, I'm just trying to get it working. I'm not going to do what I would normally do, which is to go in there and remove all of the mess that's in here. Eventually I will, if I get the thing working and want to restore it some. I'll get rid of all that junk that's in there, but for now it'd take too long, and I wouldn't be making progress on what we're trying to do to fix the thing. So let's get this thing out of here, and I'll just J-hook in the replacements for now. That guy's halfway out. I don't know if you can see it, but there's that green wire to the second IF I was talking about, where the insulation is just crumbling off of it, and it's a noisy wire too. So, like I say, that will probably need to be replaced as well when we get around to making sure it's not touching the line from this resistor, and nor that ground braid behind it. But it's kind of precarious sitting there, so we'll do something about that. Anyway, now that we got this out of the circuit, let's see if we get a different reading on it. We were getting about 65 or so before. Let's just see what we get now that it's out. Yep, I had a good reading. You can't see it. You're not watching. 66K. Okay. So that needs to come out. And we'll get this cap out as well. And this capacitor should be going between pin 3 of this and also pin 3 of the other one. So there's, yeah, that white lead runs off, yep, to the 6A7. We're down here working at the 6D6 socket because we're actually operating right in here, but it's operating right off the socket of this. So I'm going to replace that and that. And there's a white wire that runs from here to here that runs up to pin 3 of the 6A7, and that white-ish wire is running right in here. That's it right there. Okay, so let's get this fella out. And he goes to ground. Yep. I'll leave myself a little bit of a lead there in case I get a chance to test this and see what it was reading. Well, I need to leave myself some room to tie him to the ground. And we'll check him later. Yeah. Yeah, so right here we've got, just going to zoom in there just a bit. So in here, it's tied off to a lead that runs to this ground that's attached to the chassis. And looking at it, it looks like there's plenty of heat added. It looks like that's got a good connection to ground. It wasn't like somebody got in there and tried to attach something and didn't have enough heat to do any good with it. Okay, so we got to have a capacitor from here to here, here to here, and a resistor from here to here. Okay, let's get that in. Let's see, I guess I can tie them both to this line right here. I know some of you don't like J-hooking. Bear with me. We're just trying to get the thing to operate. I don't want to take the time to go in there and clean all this off right now. All right, and then I'll tie off to there. So let's see. So I'll use this guy first. Reuse some of that piping that was on there holding it. So yeah, I did grade this. So that's the foil side. I'm in the RF section, so I'm using one that I've checked. So that's the foil side. Foil side goes to ground, lower impedance side, so it'll go like that. flux relay makes it make a much better connection, and it also just makes it so much easier to solder. Get this thing in here and it'll boil away and clean the lines and make that solder flow over all these connections really, really nice. It makes it just so much faster. And if you're wondering, I have my temperature set at 680 Fahrenheit. It just happens to be sitting there. I don't make it a science. There we go. It had some big wires on it, so it took a while to warm up. That's done. Okay. Be interesting to see now that we have these two guys out, if we get a difference in voltage up there on pin 3. We'll get this thing hooked back up and run the voltage up, see what we get. Reconnecting my leads for the voltmeter on the power supply. So what I'm going to be doing here is voltage is high when there's no current going through because you're not losing any voltage through the dim bulb. You start drawing current, you lose some voltage to the dim bulb, and you have to compensate for it with the variac a little bit. Okay, 81 volts. I have glow. 100 volts. Don't see any arcing and sparking, and my dim bulb is dim, so we're looking good. Hey, listen to that. A little more noise, huh? I like hearing noise. Still at full voltage, full volume. Let me tune it between where I find a quiet spot. It's not too hard to do. And we'll see what voltages we get now. Okay, get you back up where you can see. Okay. So we're going to go to DC volts, and let's see, before we were getting 5 volts DC on that pin 3. So we can see what we get now. Let's see, so we'll go to ground, pick up ground there, and we decided that pin 3 of one connects to pin 3 of the other, and so this is pin 3 here. I can just pick it up right here. So let's see what we get. Oh, that's frustrating. So just as I was about to hook this thing up, the memory card packed it in. So I had to go remove a bunch of files, and let's get you back where we were. Can you see this? Alright, so where we were was we removed the 1 watt 33K resistor that was measuring 100% high, and this capacitor that went from that line that went between the two pin 3s on the oscillator, what am I trying to say? The converter tube and the first IF, or the IF amplifier. So that was this guy here. So replaced this and this, just hooked up ground. This had been giving us 5 volts, which was not where it was supposed to be. And let's hook this thing up and see what we got. Hey, look at that. So we're now at 61 volts. Okay, so let's see, where were we? So we looked at this earlier. You may remember we were looking at, focus, please, the screen grid voltage between 50 and 100 volts. We were getting 5 volts before. We're now getting 62 volts. That's much better. Okay. So let's see what kind of difference, if any, we get. Well, well, the station.
It starts sucking together. In Indianapolis, this game was 35-14. Titans in the half. It's still 35-14 midway through the third quarter. Derrick Henry,
well, I think we found our problem.
Rushing and 3 touchdowns. Remember, I was mentioning.
Extraordinary player like Kyle Murray and be labeled as extraordinary. And I think some of
now, while we're at it,
relationship and some of the trust in what Kyler Murray
let's
can do
measure
advance
voltage on our
in Arizona, so I think
bias
there's
cell
benefit to having Kingsbury
and see what
there,
gives
some
us
of the
what.
creativity that he's employed.
And we've had him outside, and there's, we got about a
Let me see if the voltage matters too much between 1 1/4 and let's say 1 1/2 or 1.55 volts, because that's where our watch cell batteries are.
But I didn't have any clear, so I went down there and all they had was a Olympus, which is a water base. And I just wanted to get your opinion because, I opened it up, put it on the bottom, shook it up like he told me, put it on the bottom, and it just didn't sprinkle. It wasn't soaking, it wasn't thin. I felt like I had moved a little bit of milky water on my, plywood, and because it's out in the weather and I don't really want to do a whole lot, I really wanted to seal it really good so they'll last several years. What are your thoughts?
And which product, Olympics product did you purchase?
It is their water cooler.
And I mean, there's no excusing it. A lot of people are saying, well, didn't he have a great offensive line? That's the truth. But you can excuse some of the poor performance as far as yardage and all that.
I don't think I'm getting any significant difference.
Better than he's doing this season.
All right, game getting interesting right now. Buffalo and the Chargers. Buffalo had a 24-6 lead. Chargers
So there's like 1 1/4 volts DC on the bias cell. And if I go up to 1 1/2,
Austin Eckler, undrafted player who's really turned himself into one of the more versatile backs in the NFL.
I don't hear a problem. So if I put in like, I think it's a 357 or 356, I think it's 357, I don't remember, I'll check. Watch cell battery, I think it's 1.57 volts. And it looks like as far as the bias cell is concerned, it'll be fine with it. So that's an option. I don't want to put the DC to DC converter in there. It'll just look a little too, I don't know, a little too different. But maybe rigging up something for a watch cell battery might be a little less intrusive. All right, let me get this out of the way. Let's see.
Just 1-844-201-6509. Attorney Advertising. William Stephacker Jr. is the attorney responsible for this ad. Main office, Grant, Pennsylvania.
Okay guys, let's recap. So let's see, we went through this thing and opened it up, and one of the first things we did was we knew that the symptoms were is that the fellow who had it before us had plugged it in, and he had some glow in the tubes. We don't know if they were all of them, or you couldn't see all of them, of course, because of the shields. But he said that it made no sound whatsoever. Okay, well, we found out why that was, but we started through in a very methodical way going through this. We took 80 out. Before we had any of this plugged in, we took 80 out, verified we had continuity through the filaments, and it looked okay. So then what we did is still unplugged, is we went in through some tube sockets for both 80 and one of these other tubes up here, I believe it was 66, and verified that we had continuity through these secondaries. Then we knew if we had glow that this secondary here was good, so we then plugged this thing in and without 80 in it, and measured that we had 7 volts here, we had 570 volts from either end of this coil here, and we had 5.8 volts, I believe it was, going for the filaments of 80. So we felt like we had a good enough shot here to go ahead and plug this thing in and see what we could get. So we went ahead and put the rest of the tubes in here and fired it up, and we got the same thing he saw. We saw a few tubes glowing, but we got absolutely no sound. So we went through here and started tackling this thing. And so you start thinking about the kinds of things that we dealt with. I mean, this is a good example of why you wouldn't want to go through and just do, a shotgun cap job on something like this, because this thing had a lot of different issues, and you'd be wondering all the time, did I rewire something wrong or something, as opposed to finding out there's some fundamental issues. And of course, there's a few things I wish I'd done differently, but it is what it is, and it was interesting to go through it. So we found out we had bad electrolytics, so we went ahead and changed those out. We used a signal generator and a signal tracer and went through this thing and found where we were getting the signal through. We didn't quite hear it here, but once it amplified through this one, we were able to hear it going into the 66 tube. Then it amplified it, and we heard it over here at pin 3 and 4 going into this detector tube. But then it got silent after that, and something else was wrong. I tried thinking maybe it was this little bias cell. Talk about Charlie the Lonesome Cougar, accused of a crime he didn't commit. This little guy here was not responsible for this being shut down whatsoever. But in the beginning, I was suspicious of him because he was new to me. Anyway, so we went through this and found out, hey, you know what? This primary on this audio output tube was open. And I was so close because I had gone over here and I'd done some testing on the field coil and then got in here messing around with what we had in here and said, okay, this is good. If I just worked my way backwards from here, since I had 0 audio output, that would have been one of the first things we'd found. So it would have saved a lot of trouble going through the signal tracing and all of that. Hey, lesson learned. Anyway, it was interesting to do. Anyway, so we went through this. We found we had this dead primary. The secondary, luckily, was good. We fixed the primary. Then we went through and, I called it rebuilt this audio section. We basically had to replace both of these tubes. 75 had a short in it. And 41 had a short in it, and 71 had a bad test on one of the 3 tests. I didn't even run the other 2 tests. I'd be interested in your opinions in the comments, please, about what you think happened. Do you think that this grid coupling capacitor basically went bad? The guy who had it before me left it on a long time, and maybe it caused 41 to short, basically messed up the audio output tube. And then once that shorted, did that somehow burn this up? Or did this just kind of corrode away? I didn't see any sign of burning up or anything in here. It just simply came apart. So I don't really know what happened here. But I know this is all probably related somehow. Anyway, be interested in what you think, what you think happened first or second. It'd be good discussion points. Anyway, so we went through all that and got that fixed. And then went through and did an alignment just to kind of quickly get this thing, where I could hear it and work with it and so forth. And it just kind of faded away. And so we went through and started assuming it was over here in the front end. And so we went and worked our way through all of this. And it finally turned out, went through and basically troubleshot all through the converter tube, checking all the inputs, and finally checked, what was going on with this 33K 1 watt resistor. And this guy and maybe this cap, between these two, were pulling that voltage down to 5 volts on both pin 3 of the converter tube and on the IF amplifier tube. And it needed to be much higher. It needed to be 50 volts up. So once we got this changed out, we had 60 volts up here. It looked good. And then we got the thing, that really woke this thing up. It really did. So since then, I've gone through and I've retouched up the alignment a little bit. I still haven't done it properly. The IF cans are a little tight. I'd like to open them up and clean up those caps in there. I think also that once we change the other capacitors in the sections, we may find that they're gonna drift anyway. So those will all be retouched. I know some of the wires in here are kind of crumbly. I know I need to replace this wire that goes from the second IF up to pin 3. I know that the wires that go from the tuning condenser back into the chassis, the insulation is completely gone off those wires. So I got a lot of work to do in terms of the electrical restoration. But the main thing I wanted to do with this was to get this thing fixed, because then we can go and do a restoration and not worry about, did we fix everything, or did I just mess something up, or is it got a serious problem? I still think that the antenna coil may be open. Maybe not at the beginning, but maybe back in here, because I'm still getting reception. So I think that this first part of the coil must be doing something. I don't know. And it's because we are getting signals through. But when we get into looking at the electrical restoration of this, I may take a closer look at this to see what's going on in there. It'd be interesting to take a look-see. Let's see. A few other points. At the beginning of the video, I was talking about the selector switch, and I'll talk about that in just a minute. Another thing that we did is we went through and looked at removing the lens, the lens in the front of the dial. I pulled that lens off, and there's 2 holes, and you go in with a couple of toothpicks, or I used a couple of metal probe and kind of worked it very carefully out, and was able to get the thing out. Then once it got it out, I used some Novus 2, which is something I've used for years on other things. One of these days I'll make some videos on what I've been using this on, and got it cleaned up and put it back on there. So I thought I'd like to give you a view of what this thing looked like after the dial lens got cleaned up. So you ready for the reveal? So that is not a new cover. That's the original cover that's on there. And all I did was clean it up with, this particular product. There's other products that maybe can do it. I don't know. I've used Novus 2 for years on plastics, and maybe one day I'll show you some of that stuff. But anyway, what I went through and did is I also went through and double checked what we had in terms of setting the oscillator correctly. I figured out which of the pots that were always kind of on the, not pots, the capacitors that were on the right-hand side as we were looking at the underside of the unit to see what all they did. And so if you had this thing turned up and from the top down, it was the shortwave oscillator, the broadcast oscillator, the shortwave antenna trimmer, and the broadcast antenna trimmer. And I may, when I get done with this, if I'm verified of that, I'll just probably put some pencil marks on the side of the chassis to show that. I'm not going to bother doing that right now because I may actually, go through a electrical restoration on this. I may clean top of the chassis off, not too much. I'm not crazy about that kind of stuff, but I'll take the tuning condenser off and I'll get it all cleaned up, and I may take it out and put it into my ultrasonic. I've done that on a number of other tuning capacitors, and we need to change all the other capacitors that are in this thing. All the resistors were high. They all need to be taken care of. But I thought maybe we just kind of do what the obligatory thing is, kind of go through this. Now I don't have a shortwave really antenna on here. I've got a wire that goes up to the ceiling and runs around the top. I have a portable random wire that I use set up in the backyard that I was thinking about hooking up. I may do that later, but it's raining outside right now, so I'm not going to take this thing out, and I don't want to get my wire wet because I bring it back in every night. All right, so okay, so let's jump ahead some. This is midnight after I did this recording that you're watching. So we let the sun go down and get some better shortwave performance off of what I've got set up here in this, little antenna I got set up in my garage, within all the domestic interference we've got. But thought we'd then run a scan through later at night and see what we can get here in shortwave. Sometimes you can hear WWV at 5 megahertz. Come back to it. Start to pick up a lot of domestic interference back over here in the lower end of the band. And it kind of comes and goes. You can pick up WWV pretty clearly, and then sometimes it fades out and then comes back. There it is. Okay. It's out of Fort Collins, quite a long ways away from here. Okay, we'll go back to earlier in the day. So I thought maybe what I'd do is go through and look at maybe changing a few of the knobs here, give you a kind of run through what we had. So originally, I was looking at some of the things on the schematic. Excuse me, can bring this back. And it shows these switch symbols here. And I can see it says shortwave, that's an SW, shortwave, BC for broadcast, and then there's this third position that doesn't have anything. In the first video of this thing, I said, well, I think that third position is mute. Well, I'm wrong. First thing is that this, and this is common, but you don't always know, in this case, that this is looking at the switch from the back side, okay? So Usually people will, schematics, it'll designate whether you're looking at the front or the back. If you're one of the guys that picks up one of these 588s, then basically what you're looking at is the switch from the back. So what you have is on the far right is the shortwave, and in the middle and then to the left you have broadcast. And in the middle position it runs it through this capacitor. And of course and the shortwave does as well. So the shortwave and the middle position on the broadcast goes through the capacitor, and then when you click it over this side, it bypasses the capacitor, and it takes the capacitor out of the line is what I'm trying to say. It doesn't tie a capacitor to this right here. Okay, otherwise there's a cap tying this to ground going over here to the audio, to the output. All right, so let's go through some of this. So I'm currently in shortwave. Okay, so what I need to do is turn the microphone around so you can hear the radio and not hear me. Okay, so now hopefully you can hear the radio. And like I say, I don't have really a good antenna for this. But anyway, let me just kind of run through the band here. I'm going to switch it from shortwave into the middle position, which is broadcast with the capacitor, tone capacitor in.
Mình bắt cái đường dây đấy vô. Nó chạy nó chạy.
So I got music playing. You'll hear the effect of using the tone to the left. So that's more for voice, and that would be middle position is more for music.
Ổ nào có hai dây nóng.
Tell you what we're going to do also. Let me do this with the lights out. I think it looks even better. Hold on. Now doesn't that look nice?
Comparisons with others.
Los horarios en nuestra página de Facebook, La Iglesia del Pueblo.
Party politics.
Well, we've seen this throughout the entire pandemic. That one political
So if I
party
go
is saying
to the other
one
tone
thing,
setting,
one political party is saying another. But when it comes to vaccine,
so that's the other tone setting. So it's probably better for voices.
the safe and effective vaccine, and we really need folks to choose to take it because.
Cuando yo te miro casi la disimulada. Mi amor, tú no quieres nada.
So how do they do that? Guarantee that you won't lose money in a bad year, and we can go in.
9, 14, 60. Ahora nos vamos saludando.
Chúng ta vẫn đổ lỗi đến việc bảo vệ gia đình của mình và trò.
Yeah, the major leaguers, the future major leaguers on that 2013 Quad Cities River Bandits team: Correa, McCullers, Kemp, Devo. They had recently punched the green, so the ball still rolled nice for recently being punched. Not a lot of places.
Okay, we're getting down to where there's nothing left over in this area. So I thought it'd be interesting also is if you can see my hand here, these little buttons are around the outside. I've adjusted a few of them. Let's see if this works. Push it in and turn it. Nope, that wasn't the one. Take this one. How about that? So if you're somewhere else in the dial, push that one in and turn it.
One out. Pitch to
How about
Alvarez
that?
is
And
inside
if I want to go to one of the
You're on
other ones, let's
Alvarez.
see. How would I do this?
Green for
I'm new to
fourth,
this.
three-run home run in the fifth.
Let's see if we go here. Nope. Let's try this one.
exciting. A 5% return. Well, where can you get that right now as far as guaranteed interest?
So the idea is I can put some labels on here with different broadcast names, and then I would know which one is where. Alright, so let's see, if I want to go back to the baseball game, I guess it's like, is it this one? Nope. Was it this one? Nope. Is it this one? Yep. That's it. So the way these things are adjusted, sorry to blind you. So the way these things are adjusted is that these things have a little set of slots on them. So you pop out the label that has the name of your station you want to listen to. You pop it out, and then it reveals this slot that goes across. I took a piece of metal that came from one of these metal junction boxes, and this is just about the right thickness. If you have one of these, just find yourself a piece of metal that's the right thickness, and it would fit right into those slots. And then what you do is you just unscrew it, and that loosens it. And then once it's loosened, then this can be moved around the dial. So you set it in the position you want, you move the dial into the position, and then you tighten this back down. And then just give it a light snug with this. Don't overdo it. You don't want to break it. You know, if it comes loose, just redo it. But you can see in some cases some of these have been broken off. And this is just pot metal, so you don't want to overdo it. So if I get into doing a restoration on this, I may try to figure out how to do that as well. Anyway, hey guys, I really appreciate you sticking with me on this. This has been a long one. I didn't expect it to go on as long because I didn't expect to have so many things go wrong with this thing that needed to be dealt with. But if we do the electrical restoration, I'll do the caps, the resistors. I'll do a proper alignment, and I'll look closer at the antenna coil issue. But as you can see, I'm picking up things, so at least I have something as a good platform that works, that I can start with. So as I make restoration steps, I can make sure that I didn't do something that's like what happened. I know, because then I'll know the basics of the thing is working fine. I'll come up with something for the bias cell, but you heard how it was sounding. The fact is there's no bias cell in there, and I don't even have that buck converter hooked up either. So I've just got it open, and this thing is working very well. What I'm going to do is just take a small lithium cell, a coin cell, and just solder a couple of leads to it and solder it in there in that position. It'll probably last another 50 years, and that'll be fine. And that's what my plan is for that. You saw that we tested that the voltage didn't matter. Anyway, so if I do any of this other work on this, I'm just going to, I'm going to add it onto the playlist. This has got 7 videos in this playlist, and I'll just add it to that. Look for those, because I really think this is a nice looking radio. I may go through and do it. I can't promise I'll do the cabinet. I'm not much into woodwork refinishing, but in some cases I think there's some value in leaving it like it is. But we'll see. Anyway, thanks a lot, guys. I appreciate it. Thanks for watching, and maybe I'll see you again soon on the electrical restoration. Take care. Bye.